The second click event associated with the amortization schedule button uses similar Excel objects, same input variables for amount, years, and rate, as well as a payment date, remaining principal and cumulative interest variables. We will start at the top left corner of the amortization table and then loop through all the rows and columns of the table, inserting the index of each period, 1, 2, 3, and so forth, followed by the payment dates. We then continue with the principal and interest components of each payment, calculated with PPMT and IPMT financial functions. Finally, we calculate the remaining principal and cumulative interest and insert those into the last two columns of the table. So switching back to Excel, this video is going to go through this portion of the model, inserting again the months, dates, principal, interest payments, as well as remaining principal and accumulated interest in these columns. The code to do that is contained in the same loan amortization module right here, where the code for the calculating monthly payment click event is held from the previous videos. You can see by looking at the top of the click event associated with the amortization schedule button that the financial variables are already declared, as well as the worksheet object variable, the index, the current payment date, the payment principal and payment interest double variables, and then remaining principal and cumulative interest doubles as well. So what we'll start with is we'll declare the range object variable for the top left corner of an amortization table, which will end up being this cell here, H4. Dim top cell as range. Okay, then we'll review the setting of the worksheet variable W loan to the current loan amortization worksheet in this workbook, as well as grabbing the input financial variables for the amount, years, and rate from the same three cells, B4, B5, and B6. So as described earlier, we're going to loop through this entire table. We're going to insert the periods 1 to 3, months, dates, principal interest payments, as well as the remaining principal and cumulative interest. And we'll start with one date, with a date 1 month prior to the first payment date, which will be September 1st, 2030. So the payment date, the current payment date, it's set to August 1st, 2030. We initialize the remaining principal to essentially $200,000, which is the negative of the negative becoming a positive, and cumulative interest is set to 0. Then we're going to start looping through each month of each year after setting the top left corner of the table, top cell, to W loan dot range H4 as mentioned a minute ago. Okay, and then we're going to start looping through each month of every year with the index I going from 1 to 30 years times 12 months, so 360 payments. So we'll start and we'll go through this column by column, starting with the column H, which has a column offset of 0. Okay, the row offset is the index of the loop. Okay, and so for each pass through the loop, you simply insert the value of that index, getting the periods 1, 2, 3, all the way to 360. The code for that is top cell dot offset of I comma 0 dot value is simply the index I. The next column involves calculating the new payment date. Okay, so for the next month, I'm going to use the date add function to do that. The offset for that column I is 1 off of column H, which is our sort of reference column here. And the code for that involves the following two lines. PMT date is set to date add with month for an interval, 1 for adding 1 month, and PMT date current value, which is August 1st, 2030. So after going through one pass of this loop, the first one, the payment date becomes September 1st, 2030, which is our first payment date, which then needs to be inserted into column I, which has an offset of 1 with a value of payment date. The next two columns, J and K, as shown, keep saving as you go along, down here are involved with calculating the principal and interest piece of the monthly payment, which was $954.83. The principal payment is calculated first in column J, which has the offset of 2 off of our reference column H, and the variable used to store temporarily the payment principal is PMT prints, and we're going to use a financial library and PPMT function to calculate the principal payment using rate that was set above at the beginning, current period 1, 2, 3, 4, and so forth, then total number of months, which is years times 12, or 360 altogether, and the amount of the total amount of the loan, which is the negative 200,000, to get the positive principal payment. And then we're going to use the clipboard to paste down the second offset and PMT prints as the value. Okay, so the interest payment calculation is very similar, so I'm just going to copy both of these lines and modify them. So instead of PPMT, I'm going to have IPMT. Instead of PMT prints, I'm going to have PMT INTR for interest. Okay, and the column that we need to put that interest in is number 3. Okay, copy, paste, should complete that column, which leaves us with the final two columns for the remaining principal and cumulative interest. So the remaining principal is essentially the principal balance after each monthly payment is made. So rem prints is the initial rem prints, which you may remember was set to the entire $200,000 at the top, minus the part of the payment that goes toward the principal, which was calculated in step 5 over here. Okay, so this is the balance after the first monthly payment was sent in, and it clearly will continue to rebalance and keep going down. I'm going to copy one of the offset on the last offset rows, and I'm going to assign the fifth column, right? Let's make sure fourth column, column L, to the remaining principal. The calculation for the interest is the opposite. Just let me insert a couple of blank rows at the bottom so you can see this, in the sense that the cumulative interest accumulates starting with 0 at the top of the loop or before the loop, plus any payment interest made in a current month. So it's clearly going to go up, and then we're going to copy the last offset line and replace 4 with 5 and remaining principal with cumulative interest. Okay, I'm going to save all the changes, review, make sure that we didn't miss any of the steps. So after declaring the top cell as range, we set it to H4, which is the top left corner of the cell, and that's our sort of reference cell and reference column, as well as the reference row, I suppose. And then we looped through all 360 months of the 30-year loan, assuming it is a 30-year loan, inserting the period numbers 1, 2, 3, and so forth, payment dates after adding 1 month to the previous payment date, calculating the principal portion of the payment, the interest portion of the payment, inserting them in columns J and K using the offsets of 2 and 3, and finally using offsets 4 and 5 after calculating remaining principal by subtracting the principal portion of the payment from the remaining balance. We inserted that in column L, and finally in the last column M, we were inserting cumulative interest after accumulating starting from 0 and going up with each month in each iteration of this loan. So going back to the worksheet, if everything works okay, hitting the button, we'll find that one of the variables was misspelled somehow. Going back, I'm going to try to run it again, and we'll see something else is wrong. Oh, no, it's okay. With a couple of hiccups, we get down to the bottom where the loan is completely paid off and interest accumulates to a substantial almost 150,000 on a $200,000 loan, which of course part of it is tax deductible and so forth, which is really not part of our discussion. Switching back to the presentation, this is a good place to pause.